Hello, this is a weekly summary of interesting news that is relevant for my distributed systems lecture at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Bocek and today we'll discuss 5 topics. The first topic is about the Trump memecoin. And in January 2025, President Trump launched a cryptocurrency called Trump on the Solana blockchain. 1 million coins were created, with 800 million kept by Trump-owned companies and 200 million sold to the public. The coin's value jumped quickly, reaching a total market value of over $27 billion within a day, and the project has generated at least $350 million through token sales and trading fees. And it is currently valued around $2.5 billion. And in April, Trump announced a special dinner for the top 220 holders of this coin. To qualify, investors would need to own 4,000 Trump coins worth roughly $54,000. The top 25 holders, who owned around 325,000 coins, each worth $4.2 million, got access to a private reception at Trump's golf club. And the article mentions that investors dumped tokens around the 12th of May, and that 100 of the 220 attendees got rid of almost all their Trump holdings, including 17 out of the 25 VIP guests. But looking at the price, we see here around 12, there was a spike. It was almost at 15. It was declining until it rose again to 14.7, and now it's at almost $13 per Trump coin. At the actual dinner, the attendees reported mixed experiences. Trump spoke for about 20 minutes, covering his election victory and crypto policies, then left by helicopter without taking questions or photos with most guests. The event lasted only 23 minutes for regular attendees, and interestingly, many guests were checking their phones for the coin's price movement. The next article is about the Windows Subsystem for Linux. It's the following article here. Microsoft has announced that Windows Subsystem for Linux is now open source. The code is available on GitHub, allowing developers to develop, build, and contribute to WSL development. This decision comes after years of preparation and addresses the first issue ever raised on Microsoft's WSL repository, asking if it would become open source. WSL consists of several distributed components that work together across different environments. Here we see an overview. Some parts run in Windows, while others operate inside WSL2 virtual machine. And the main components include command line tools like WSL.exe, the WSL service that manages the virtual machines and file sharing, Linux processes that provide WSL functionality, and Plan 9 server implementation for file sharing between Linux and Windows. WSL started in 2016 with the version 1, which ran Linux programs directly on the Windows kernel using a Pico processor provider. And then WSL2 announced in 2019 switched to using an actual Linux kernel for better compatibility. This represented a shift from kernel level integration to a distributed virtual machine approach. For the challenge task, WSL is essential if you want to work on your challenge task, as it requires to use Docker. And I think this release by Microsoft is an effort to prevent developers from switching to Linux entirely, so you can access Linux tools while staying in the Windows ecosystem. On the other side, in the corporate world, you are often required to use Windows, and with this you maintain productivity when your IT department logs you into the Microsoft ecosystem. The next two articles are about conflict-free resolution data types, in short CRDTs. This is the first article here. This is an alternative approach to collaborative text editing that claims to avoid the complexity of conflict-free replicated data types and operational transformation. Instead of using ordering algorithms, this method uses an insert after operation with globally unique character IDs. And the core idea assigns each text character a unique ID, typically a UID, creating a data structure of ID character pairs. And when user makes an edit, clients send insert after operations that reference existing character IDs rather than array indices. For example, instead of saying insert text at position 17, the operation becomes insert text after character with ID something. The author argues this method avoids the mathematical complexity of CRDTs and operational transformation. However, this approach seems to be very close to causal trees minus the logical clocks. And keep in mind, CRDTs are fundamentally defined by properties like commutativity, associativity, and idempotence rather than specific algorithms. Another CRDT article, or two actually, this one and this one, they were published at the same time. And the first is a brief introduction, and in the second article he points out that many CRDTs secretly assume things like message arriving in order or clocks being synchronized, but they don't build these assumptions into their core design. And the author shows that with a simple system that tracks which item are added or removed from a set. To save memory, old deletion record needs to be cleaned up, and a basic approach using local timestamp can cause computers to never agree on a final state, creating an endless loop where items keep switching between added and removed. And the solution is to explicitly track what each computer knows about what other computers have done. And this uses something called version vectors to safely determine when it's okay to delete all records. Only when all computers definitely know about a deletion can the record be safely removed. Very interesting articles, and I will cover CRDTs in the upcoming fall semester. The next article is about supply chain attacks. It's the following article here. Security researchers discovered malicious software in the NPM repository that went undetected for over 2 years and had more than 6,000 downloads. 8 packages with names closely to legitimate tools contained destructive payloads designed to corrupt data and crash systems. The malicious packages used multiple attack vectors targeting different parts of the JavaScript ecosystem. Some deleted Vue.js frameworks, files, using commands written for both Windows and Linux. Others corrupted core JavaScript functions with random data or attacked browser storage mechanisms, breaking authentication tokens, user preferences, and shopping carts while creating hard-to-diagnose intermittent failures. And the most sophisticated attack used multi-phase approaches that deleted framework files and forced system shutdowns. Many payloads were programmed to activate on a specific date in 2023, with some phases having no termination date, making the threat persistent. The attacker created a facade of legitimacy by uploading both malicious and working packages onto the same NPM account. This mixed approach helped the harmful packages to avoid detection while targeting users of major JavaScript ecosystem, including React, Vue, and Vite. This attack highlights a fundamental vulnerability in modern software development. When you import dependencies, you're essentially running untrusted code on your machine with full access to your system. Containers during development can mitigate such an attack vector. The last article is about the Cetus hack. It's the following article here, and over 200 million of assets were stolen. Cetus is a decentralized exchange built on the Sui blockchain, and they experienced a hack that drained 223 million in digital assets. Blockchain analysts detected massive fund movements with at least 63 million bridged to Ethereum and 20,000 ETHs transferred to fresh wallets in single transactions. Cetus processed $2.9 billion in transactions on May 22nd compared to 320 million the previous day, indicating large-scale asset drainage from the protocol. Cetus confirmed that 162 million in assets have been frozen, and the attacker's address contained nearly 52 million in Sui tokens, 19.5 million in wrapped USDT, and various other assets across multiple cryptocurrencies. The Sui network demonstrated coordinated response capabilities when validators collectively identified addresses containing stolen funds and began ignoring transactions from those addresses. This shows how distributed consensus mechanisms can be used defensively, though it raises questions about decentralization when validators coordinate to block specific addresses. And a very good analysis is here at Rect News. The attacker drained the funds using a mathematical vulnerability in their liquidity calculation formula. They deposited just one token in a very narrow price range, approximately 200 ticks apart, which caused the get liquidity from a function to divide by nearly zero. So here's the breakdown how the attack worked. The attacker first took a flash loan of 56,000 Sui tokens. Then he created a liquidity pool position between ticks between 300,000 and 300,000 and 200, as mentioned, just 200 ticks apart. Then deposit one token, and here the math breaks. Dividing by almost zero creates a massive liquidity. Here we have this massive unit of liquidity, and then you can withdraw twice, once to repay loan and once for the profit. And step 6 is you can repeat this all over the pools. And despite recent audits by top firms, including Zelig, they completed it on April 11th. The vulnerability was not in the scope of this audit. It was out of scope because it was outside of Cetus core code, so they did not review that. So that's it for this week. Next week, we will announce the challenge task winner.